So we just studied relations, and now we're going to look at specific types of relations called functions. And so what we're going to do first of all is look at these two different relations. So observe the two relations below. What is the value of each relation when x equals 2? So we'll go ahead and look at our relation f. So notice they're named with letters here, so that's relation f, and this is relation g. When x is 2 in f, we see that the y value is 3. Over here, when x is 2, we actually have two y values. We have a y value that's at 1, and then another one that is at 2. And that demonstrates the relationship of what a function is. So we'll go ahead and look at that. The first one, relationship f, is a function, whereas g is not a function. And so here's the definition of function. It is a relation. So remember, relation's a set of ordered pairs, so we could say it's a set of ordered pairs in which every domain element, and we remember that's the first one if we write in our ordered pairs, is paired with one and only one range element, or the second coordinate. And so here I have an example of a function and an example of something that's not a function. Notice in the one that is a function, 2 is paired with 8, and only paired with 8. 3 is paired with 7, and it's only paired with 7. It's not paired with any other numbers. And then -1 is paired with 5, and it's not paired with anything else. But over on this other one, we notice that -1 is paired with 4. I don't see -1 anywhere else in the two things. But then when we see 2 is paired with a 7, but it's also paired with a 9. And so that one's not a function because 2 is paired with two different numbers, the 7 and the 9. So here we have an example. It says, give an ordered pair that you could add to this relation that would make it not a function. So as of right now, this one is a function. This relation is a function because 7's paired with just -4. We don't see 7 paired with anything else. 6 is just paired with 1, 4 with -3, and 10 with 0. There are tons and tons of options we could have here for adding a ordered pair that would make this not a relationship, not a function. And so I'm just going to put a 7 here. 7's paired with -4, so if I pair 7 with anything else, like 9, this thing is no longer a function. I could have done 7, -2. I could have chosen 6 as my first coordinate and picked anything else except 1. So 6, -1. So those are things that would make it not be a function. Just to clarify, I'll mention this again later probably, could I have added 3, -4? So I don't have a 3 here in my x values, but I do have this -4 right here. Is it okay for this two different x values to be paired with the same y value? Yeah, that's fine. That would still be a function if we added this, because it's as long as the x value isn't paired with more than one y value, but it can be the other way around, and that's no problem. We can tell if a graph is a function by using what's called the vertical line test. The vertical line test says if 2 or more points of a graph lie on a single vertical line, then their relation is not a function. So what we'll do is, in this example, we're going to go ahead and graph this relation and see if it's a graph the relation and explain using the graph whether it is or is not a function. So we have these different points, -2, 4, so we'll graph that point. So -2, 4 is here. We have the point -1, 1. We have the point 0, 0. We have the point 1, 1, and the point 2, 4. And we want to know, is this a function? Well, what we can do is we can take a vertical line and move our way across here. Does this vertical line ever pass through more than one point? It never does. It passes through 1 point, 1, So this is a function. And it's a function because it passes the vertical line test. It doesn't, there's no vertical lines that pass through more than 1 point. And so that's important. Here we have what I like to call a function machine. And so this is the idea of a function. And functions are important because if you put something into a function, you will only ever get one answer out of a function. One example we can think of is at a grocery store. You want the barcode readers to be functions. So when you bring up your Reese's peanut butter cups and scan it, you're hoping that when you scan it, it will give you one price and the same price every time. You're not taking that up there thinking this could be 75 cents or it could be $60. That barcode is paired with only one price. That way when you go up there, you know you will get the price. So that's one example. So this function right here, this function machine, it takes whatever x value is put into it, it multiplies it by 2 and subtracts 7, and then outputs whatever that is. So when we can take a number, we can put it in here, put it in a 3. It performs the function. So it's going to multiply that by 2 and subtract 7, and it will probably make some type of noise like do-do-do-do-do. And output is -1. So we put in 3. We got 2 times 3 is 6, minus 7 is -1. We can put another number in there for the input. We might put a 10. So put in 10. 2 times 10 minus 7, do-do-do-do-do, you get 13. And we could keep doing that, and we can put something in and you get an output. Function notation. Usually, or oftentimes in algebra, we write things like this: y equals 2x minus 7. We have another notation where we have f of x equals 2x minus 7, or the function of x equals 2x minus 7. So f of x really is the same as y. X, just like y is the independent variable, just like y is the dependent variable, f of x is the dependent variable. So x is our independent, y is, or f of x is the dependent. So here's an example. Evaluate f of x equals 9x minus 4. Here's one advantage of using function notation. I can have my x value, the number I'm plugging in for x, right there in part of the equation. So f of -3. So here's my function. When I'm asking for this domain for x equals -3, 2, and 4, I'm going to put -3 in for x. So that's 9 times -3 minus 4, which is -27 minus 4, which is -31. So that means f of -3 is -31. Then I can take 2 and I can put it in the function. So f of 2 is 9 times, I'm putting 2 in for x, minus 4. 9 times 2 is 18, minus 4 is 14, and so we know that f of 2 is 14. And then lastly, I can put this 4 in. We have f of 4 is 9, and whatever number is here is what I put in for x. So 9 times 4 minus 4, and that's 36 minus 4, which is 32, which I could write f of 4 is equal to 32. And so that's using function notation. And again, by looking at these over here, I can just look at this, and I know that when I put -3 in, I got -31. Whereas if I took this and put 3 in, sorry, -3, minus 7, that would give me 1. actually negative 13. But when I have y equals negative 13, this answer, that doesn't tell me that I put a negative 3 in for x. And so that's an advantage of function notation. Another advantage is I could have this function, which I might call f of x, but I might have another one called g of x, and I can differentiate between the two of them. Linear functions, we'll definitely get into this more next lesson, but a linear function is a function whose graph is a line. The standard form of a line is ax plus by equals c. It has an x and a y. X the first and y the first. And then a, b, and c are just real numbers. So to graph linear functions, so we'll do this now. Later we'll learn a better method. But find several ordered pairs by plugging in random x values and find the corresponding y values. Then you can graph those points that we find in our first step and then draw a line through those points. So here's one way of graphing a line. This we would read graph all points x, y so that, we read that line so that x plus y always equals 3. And so we can think through this. I want x plus y to equal 3, so if I pick an x value, I'll start easy. If x value of 0, 0 plus what equals 3? Well, y would have to equal 3. What about if I picked 1? If I put 1 in for x, 1 plus what equals 3? So that's 2. I could put 2 here and have a 1, 3, and 0. We could pick other numbers. These are probably the easiest 4, but we could put something like negative 4, and I could think negative 4 plus what number would give me 3? Well, negative 4 plus 7 would give me 3. So there's several points that I can graph. So here's the point 0, 3. So 0, 3, I have that point. I have another point 1, 2. So over 1 up 2. The point 2, 1 is here. Moving on, we have 3, 0. And then I have this one that I did last was negative 4, 7. Which is here. So I graphed those several points. That's step 2. And then lastly, I'm going to draw a line through those points. And so we draw a line through those points. Sometimes it's good to use a straight edge. Obviously, I missed my point some. But that is the graph of that line. And that is our introduction to functions. We'll be seeing functions often throughout this course.